Hi friends! Today we're going to talk about combining like terms, which is another way that we can simplify expressions. So first, let's talk about what we mean when we say like terms, okay? So like terms contain the same variable and the same exponent. Okay, so basically what has to be true is they have to match. So, for example, we can't, if we think of this in a real life situation, if we have 3 apples, I'll even write this down. If we have 3 apples and 4 oranges, we can't just combine them and say we have 7 or apples or apple oranges or whatever you want to say. We can't just mix them together and say we have 7 of them because they don't match. They're not the same. So we can't do that, all right? If you are ordering 3 milkshakes and 2 fries at a drive-thru, they can't order or combine them together and give you 5 fry shakes because they're separate things. So we're going to do the same thing with our terms, okay? So only things that match can be added together. So over here on the right, we're going to circle like terms. And this, if you color code, is a good time to do that. We also can differentiate with shapes. So let's start just right here with this x. So we've got 3x. Where else do we just see an x? Well, I see one right here with negative 8x. I see one right here with negative 3x. And I see one down here with x. Now you might be saying, wait, I see another x right here. And that is an x, so the variables match. But you'll notice it has this exponent right here, which means it doesn't match completely because the exponent on each of these, even though it's invisible, is 1. And so even though the variables match, the exponents do not. So they are not like terms. Okay, but let's look at that 8x squared. Okay, so either can use a different color or you can put a square instead. Do we see any other x squareds here? Well, if we look directly above it, we see negative 7x squared in this spot right here. And then what else do we have left? I'm going to do a squiggly underline. We have our 9y, and what also matches is 4y. We have 6y and 2y. And all of these have a variable of y with no exponent, so we know they are like terms. They match. Okay? So now let's talk about combining them. So we have 2 steps. First, we're going to identify the like terms. So we need to identify what matches. And then, second, we're going to combine the coefficients of the terms. And as a reminder, a coefficient is a number being multiplied by a variable. It's also, you could think of it as the number that is attached to the variable, but it is attached with multiplication. Okay, so if we go back up here, and I'll switch colors, this 3 right here is a coefficient of x. This negative 7 is a coefficient of x squared. This negative 3 is a coefficient of x. this 4 is a coefficient of y. And we can do that for every single one of these terms. And then right here with the x, there is a coefficient even though we don't see it. It's an invisible coefficient of 1. So that's also important to remember, is if you don't see a coefficient, the invisible coefficient there is 1. Okay, so we're going to find our like terms, and then we're going to combine, so add or subtract the numbers that are attached to them. All right, so let's go to our second page, and let's look at some examples. So our first one, let's start by identifying, and I'm going to identify by doing my circles and boxes and colors and so on. So whatever you have with you, you can use that to help you. So I'm going to circle my 3x in blue. I'm going to make this a little bit. There we go. That's better. My 3x in blue. And I want to find other x's, so other like terms. I see a minus x right here. And notice that I'm also circling the operation so I don't lose it. That's a common mistake that students make, is that they just circle the x and they forget that there's a minus in front of it. And then I also see a plus 12x right here. So those are all of the x terms. And then the other terms I have are a plus 5y, and there's nothing else that matches that. So that's all I'm going to write. Okay, so I'm going to start with everything that I circled in blue, and I'm going to combine just the numbers, the coefficients in front. So I've got a 3, a minus, and remember the invisible coefficient here is 1, so minus 1, and I've got a plus 12. So 3 minus 1 is 2, and 2 plus 12 is 14, and then I need to remember to include my variable 14x. Okay, so I have 3 x's, I subtracted one of those x's, and then I added 12 more x's on. You can think of the variables like x's as actual physical things. So you have 3 x's as like, you could even think of like a piece of paper with an x on it. You've got 3 of those paper x's, you take away one of them, and then you add 12 more x's into your pile, so you have 14 x's total at the end. And then our 5y doesn't get added or subtracted from any other y's, so we just include it on the end. And this right here is just our answer. 14x plus 5y. All right, let's look at our next one. So we're going to start, like we just started at the beginning, 9x squared. Where else do we see an x squared? Well, we've got one right here. Minus, and notice I'm circling the minus, minus x squared. Okay, let's look at other terms that I have. I have a plus 4x, and the x is different, a different term than the x squared, because the variables are different. So there's I'm sorry, not the variables, the exponents are different. The variables are the same. The exponents are different. Right here we have an exponent that's invisible, but it's a 1. And right here we have an exponent of 2. And so since they don't match, they're not like terms. And then, oops, I already did a square. I'm going to do my squiggles again. I've got a plus 2y, and that's separate also because it's a different variable. So let's look at our coefficients. We've got a 9 right here and a minus, and remember the invisible coefficient is 1. So 9x squared minus 1x squared, so taking away one of those x squareds, is going to give us a total of 8 x squareds. And then I'm adding on my 4 x's, and I'm adding on my 2 y's. All right. Last one. We've got a few more that we have to focus on now. So let's start at the beginning. Just as it doesn't actually matter which type of term you start with, but the beginning is just a place to start. So this, our variable, is a y. So if I look for my other y's, I've got a plus 5y right here. Okay, and those are all the y's I have. So if I move on, now I've got a minus 3x squared, and I have a plus 2x squared right here. And then to finish, I've got a minus x, which is different than the x squared because it's got an invisible exponent of 1. Okay, and I made this confusing because I circled it, but these are different. All right, so now let's combine what we have. So here we have -8 plus 5. So -8 adding 5 on gives us -3 y's. And then for our next, we've got -3x squareds, and we're adding 2 more. So -3 adding 2 gives you a -1 x squareds. And if you wanted to, whoops, that's very large. I didn't mean to do that. If you wanted to, you could leave off that 1. You don't need it, or you can keep it on. Whatever makes most sense to you is totally fine. Both of them are correct. And then at the end, we have our minus 7x. Okay, so this also could be just minus x squared. It doesn't matter. All right, and that is our final answer. We can't combine anything else. We can't combine y's and x's, and we can't combine x squareds and x's because they don't match. They're not like terms. All right. And that is all I have for combining like terms.